let's look at finding a cosine for a point that is not on the unit circle. When a point is on the unit circle, you can simply use, in fact, let me write unit circle. You get an x and a y, and if you have that point, then automatically the cosine is the x value and the sine is the y value. So this would be the cosine and that would be the sine. But that's not true if you're not on the unit circle. What happens instead is that you use the radius. The sine is the y value, such as 2, divided by the radius. On the unit circle, the radius is 1, which is why it's 2 over 1 or negative 6 over 1. But we're not on the unit circle. So we have to find the radius, because then that would enable us to find the sine or the cosine, or the cosecant or the secant. Tangent and cotangent only need y over x or x over y. So that means our job here is to find the radius. Now, this part about exact answer we need to talk about, because exact answers need to be usually in square root form, or, then this is showing that that's not acceptable, you have to simplify, or you have to rationalize and get rid of the square root on the bottom. Okay? And you can't approximate it or round it at all. So when we do the radius here, we're going to find that we're going to get a square root answer, and we're going to have to leave it that way because then only then is it an exact answer. So what we need is to find the radius, and here's what we want to look at. Okay. That negative 6, 2, let's do a little graph here. 1, 2, 1, 2, 3, 4, 5, 6. This would be negative 6. This would be positive 2. So this is where that point is on a graph. The unit circle, mind you, is where it's 1, the radius is 1. So this part is the unit circle. The rest of the graph, you have to find the sine and cosine by finding the radius. Because look at what happens here. This is the distance of 6, going out to negative 6, and this is a distance of 2. And if we come here, this is the radius. I don't even need a, let's make a regular right triangle here. Because now the radius is the hypotenuse of this right triangle. And we know A and B. I can call A and I can call it B. Well, B is negative 6, or distance of 6, and A is 2. And in fact, what we can think of is x squared plus y squared equals r squared. That's the same as a squared plus b squared equals c squared. A squared plus b squared is c squared. Doesn't matter if it's x or y, which one, x squared or y squared. So here we can say negative 6 squared plus 2 squared is equal to the radius squared. So that's 36 plus 4. So that's 4 is equal to radius squared. But that means the radius is equal to plus or minus the square root of 40. Distances cannot be negative, so you can throw out the negative one. But square root of 40 is not acceptable. That's the same as the square root of 4 times 10, which means it's 2 square root of 10. So remember, that's one of the things about numbers anyway. Square roots must be simplified, and in this case we have to do that. So for the sine value, sine of theta, I should put it, is equal to the y value, 2, divided by the radius, 2 root 10. The 2's cancel, leaves a 1 and a 1 there. And then the next part, you cannot leave a something like this here, a square root on the bottom. So that means we have to rationalize by multiplying by that square root, which gives us a 10 on the bottom and no more square root. On the top, it's perfectly fine to have a square root. So this then is the sine of theta, but we're being asked about the cosine of theta. So for the cosine of theta, I meant to do it like that. Cosine of theta, of the angle, whatever this angle amount is here, we would do the negative 6 over the radius of 2 root 2. 2 root 10, my mistake. Apologize. The 2 goes into the 6 3 times, so it's negative 3 over root 10. And of course, always the negative on top or bottom needs to be put in the middle for normal convention. We're going to have to rationalize it again. Okay, so that makes this 10 on the bottom, so it's a negative. Let's rewrite it so I get the negative in the right place there. And then 3 root 10. So this would be our answer for the cosine of theta. Now, there's a practice one at the bottom. Please do that one yourself right now. Stop the video for a moment. Go ahead and take your time to do it, following the example of the first one, and I will, in about 5 seconds, I will start doing it. That will give you time to restart it after you've done it. Okay, it's time now. For the sine of an angle, we need to know the y value over the radius. Here's the y value, but we don't know the radius. So for the radius, we are going to do r squared is equal to x squared plus y squared. R squared is equal to that x, 5 squared plus, oh, there's a negative, let's put it in parentheses. R squared is 25 plus 9, r squared is 34, r is equal to plus or minus the square root of 34. Again, we don't need the minus or the negative because it's a distance. That means up here we have negative 3 for the y, square root of 34 on the bottom. Can't leave it that way. Oop, can't take anything out. That's 17 times 2, and neither of them are perfect squares. So we'll multiply by the square root of 34 in order to rationalize it. We get a negative 3 root 34 over 34. And that's the sine for this point, or for the angle that goes to that point. We don't need to find the cosine or the tangent or the others because this is only asking us for sine. But we could do that by using the same x over r, y over x. For these three, we would simply take these and do the reciprocals of them. Okay? And you're going to have to do that, so make sure you are ready for doing it like it shows in the book and practicing it. Now, let's look at special cases from the unit circle. So we'll now work on the unit circle for a little while. And for the unit circle, I do not have a copy of it close by. So you'll have to look at your copy that I've provided already. And I will simply remind you for these special cases, at 0 degrees, which is right here, we have an x value, let's go over here, an x value of 1 and a y value of 0. For 90 degrees, which is right here, we have an x value of 0 and a y value of 1. For 180 degrees over here, we're at a negative 1 and a 0. For 270 degrees, it's at 0 and negative 1. Okay. Now, the sine, because we're on the unit circle, and let me put a reminder here that's on the unit circle, the sine at 0 is the y value. The cosine at 0 is the x value. The tangent is going to be the y value divided by the x value, which is 1. Anything, 0 divided by anything except 0. If it's 0 on top, that means that's a 0. The cosecant of 0 is this one reciprocal. Since that's 0 over 1, that's the same here as 1 over 0. Oops, we can't divide by 0. Notice 1 over 0 is not equal to 0. Never make that mistake. I will always count that as wrong. What happens when you're dividing by 0 is you can't do it, so the correct answer is to say undefined. That's the only answer to accept for this. Undefined. The secant of 0 is going to be the reciprocal of 1, which is just 1. The reciprocal of, for cotangent, the reciprocal of tangent is to flip that and make it 1 over 0, so we have the same thing where it's undefined. Undefined. Now for 90 degrees, the sine is the y value, the cosine is the x value, the tangent is y over x. Whoops, 1 over 0 is not allowed. That's undefined. The cosecant now is going to be the reciprocal. 1 over 1 becomes 1. The reciprocal, since that's 0 over 1, the reciprocal becomes 1 over 0. Can't do it, so it's undefined. The cotangent at 90 degrees, well, here, that was undefined because it was 1 over 0. But when you do the reciprocal of that, you get 0 over 1, which is 0. So there is a cotangent for 90 degrees. Do the next ones yourself. Take a moment, turn off the video if you need to there, and do it yourself, and then I will come back to it. Okay, start the video now, and by now you will have started it again. Sine of 180 degrees, 0. Cosine will be the x value, -1. The tangent is going to be 0 over -1, which is 0. Cosecant will be the reciprocal. Oops, you'd have 0 on the bottom. That one's undefined. For the secant of 180, the reciprocal of -1 is -1. -1 over 1, flip it, 1 over -1 is still -1. Here, we're now going to have 1 over 0. Whoops, can't do it. So this one is also undefined. So, next here, the sine of 270, okay, is, sine immediately, that's -1. The cosine is 0. The tangent is -1 over 0. Can't do that, so this is undefined. The cosecant is the reciprocal of -1, which is -1. Oh, the reciprocal here of 1 over 0, so that's undefined. The reciprocal of cotangent, well, this was undefined because it was -1 over 0. Now it's 0 over -1, which is indeed 0. Okay. That's part 1 of this section 11.3.